Yes, sir.
Okay. Fine. So with constant, if a medium between plate is having dielectric constant K, so C will be equals to K epsilon naught A by D. Make a note of these formulas. I hope you're doing the same way, right? I told you to make a small notebook or a diary or whatever, very small, like let's take 2-3 inches, not bigger than that. In that, write a formula. We are using this formula for this one, a note for this. Same way, second formula for this reason, some note. Same way, or some important notes about it. This will be a time saver during your exam. Are you doing it?
Yes, sir.
Others? If not, then start now. Start today itself. Okay. Then next, spherical capacitor. Now, I'll draw a sphere here. So this sphere has some radius, small radius, and radius bigger. Okay. This, let's say this as a capital R. Okay. Or and small r. Or let's take both as R only. R1 and R2. Okay. Now, there are two plates. Or let's take a concentric spherical plate. Okay, that will be better. Of radius R1 and R2. Okay. In this, there is a space between them is filled with a dielectric. I'm not writing those things, just you can understand. Space between them is filled with dielectric K. So then there will be plus, 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 plus. So this will be minus, 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 minus. One second, let me mute it. Okay. Okay. So there are two concentric spherical plate with radius R1, R2. These all are conducted as you know already. So let's start with the formulas. when outer conductor is earthen. So the formula will be like this. Spherical means 4 pi area we have. Epsilon naught R1 R2 R2 minus R1 for without dielectric. Now with dielectric, just we need to add K. With when it is earthen. Is earthed. Inner sphere is earthed. So it will be C 4 pi epsilon naught K R1 R2 by R2 minus R1 plus 4 pi epsilon naught R2 for smaller sphere. We are not deriving this side either, because if we do derivation, then it will be taking more time. Okay, so let me give you for this small explanation. Have you written? Shall I scroll it a bit up? I want to show you diagram again.
Completed.
Okay. Okay. Now this, see, we got this combination. Okay. So because there are two capacitors here. And actually, if we consider this one as a parallel plate. Okay, so one capacitor is, this parallel plate is formed as a circle inside and outside same way. So this actually a similar to parallel plate capacitor. So this we have similar formula for parallel plate. We are just changing this area and radius obviously. We have R1 here, there we took D. So we have similar formulas. So this behave as a two capacitor. So if we want to write, let me write as a point. This behave as a two capacitors in parallel. It's actually no need to write here, or we can see, or it's visible here itself. So no need to write that. Okay, let's do some question. This is some exam question with this. parallel plate capacitor is maintained at a certain
Sir, can
potential.
you show the up point?
Question, okay, yeah. This one was still up one.
No, sir, done.
Done. Take it. A parallel plate capacitor is maintained at a certain potential difference when a 3 mm slab introduced. Between the plates. In order to maintain the same potential the distance between plate is increased by 2.4 mm. Okay. Find electric constant of the slab. It's very easy question. Read the question carefully. But okay. Now, in this case, we need one more formula. I think so. We didn't write here parallel plate. Yes. Just small changes in that formula. I'll do it here. Now, this is for if space between the plate is partially or partly filled with dielectric. Okay, then formula will be a little bit different. It will be C equals to epsilon naught A D minus T 1 minus 1 by K. This will be a formula. So here T is thickness of that dielectric. Okay, thickness of dielectric, K is constant, dielectric constants, and D is the distance between them, that you know. So here T is the thickness of dielectric. So how much thickness it is? So we have a slab here. Okay, that's why I gave formula here. So here T it is 3 mm. 3 to 10 to power whatever. Okay. So better I will solve here. So first let me write given terms. I'll forget. Distance
Sir,
between, yes.
for this, won't there be one more equation that when there is like no dielectric between the plates, then what will be the formula? So that we can equate those two equations and then substitute.
Yes, we can do that. Anyhow, we are going to do that only. We are going to find out this value and comparing with this equation. Not this equation. We are going to compare these two equations. So E and A will get cancelled. So remaining thing we need to find out. 2.4 mm. It's a new distance between them. So here increase by 2.4. That means D plus 2.4, whatever D was, it is new D equals to D plus 2.4. So here let's take as D1 or D dash. So D dash equals to D plus 2.4 mm. What else we have? T equals to 3 mm. Okay, so let's compare. Equals to epsilon naught A D plus 2.4 minus 3, 1 minus 1 by K.
Sir, is K is 5?
Yes. Oh, 1 second. Yeah, K is 5. D equals to D plus 2.4 into 10 to power minus 3 minus 3 into 10 to power minus 3 into 1 minus 1 by K. So this DD will get cancelled. So we are left with this values. So find out K from here. Check, are you getting K as 5? What do you do? This send is on other side, it will be plus. So then send is on division. So it will be 2.4 divided by 3 equals to 1 minus 1 by K. Then so on, we can do it. Point 0.6 by 3. So reciprocal 3 by 0.6 means 5. Yes, it should be 5 only. Are you getting 5, everyone? Yes, guys, done? 5?
Done, sir.
Others? ठीक है. No, let's try this one, then we'll do one more exam question. Yes, we have enough time. Spherical conductor. This is not exam question, this is just example question. Easy. A and B. It shows B is greater than A. Are placed concentrically in air. B is given a charge plus Q and A is earthen. Okay. Here A is earthen. That means inside. Find which formula, inside formula did we have written? Inside sphere is earthen. Okay, fine. We have. Yeah, use directly formula. Come on, start doing direct formula and solve it. Very easy. Give a radius name A and B. It's already given. Draw circles. Till then, I'll finish this writing question. Okay. System. Do you want me to draw or will you do it?
Will do, sir.
Good. It's very easy, direct question. So you should do this question because it's not an exam question. Simple question. Radius A and B. What's the answer you're getting? Pawan Kumar, are you able to do this question?
Yes, sir. Yes, sir. Doing so.
Very good. Sai Charan,
Yes, sir.
doing?
Doing, sir.
Okay. Shruti,
Doing, sir.
okay. Jafar, okay. So today I'm going to send after this class a JEE practice questions, but actually this will contain all full topic about this. We haven't finished, but especially I'm going to give for the students, those who are going to appear exams next coming exam. Like Shruti is giving exam, Jafar is giving, who else? Upcoming month, anyone is giving exam except Shruti and Jafar?
Sir, JEE only or NEET also, sir?
Both
I'm giving next month.
next month, right? So you can solve that questions. Do you need solution with that, or I haven't prepared solution, but you try those questions.
We'll try, sir. Afterwards, you post the solutions also, sir. Then we'll check out.
Yeah. Okay. Means 4 of you are giving from this.
Sir, done this question.
Done? Okay. This is a different question. Good. Apart from that, we will do now. Some questions we'll do now. Not those questions. Okay. Fine. Oh, done this one, right? So what's the answer you're getting?
So it's 4 pi epsilon naught b squared by b minus a, sir.
Yes, sir, same answer.
But here it gives us 4 pi epsilon naught b square by b minus a into b. Is it? Did they miss anything?
No, sir.
Yes, they misprint here. No, correct. Your answer is correct. It cannot be b square here because here, if we take b common, where is the formula? B common here. It will be only one b. Yes, it will be only one. Correct. This is printing mistake here. So answer is 4 pi epsilon naught B square by B minus A. Everyone's getting same?
Yes, sir.
Super. Okay. So let's go with series parallel first. Then we'll go with series parallel numericals. No, not question. Series combination. Formula, anyone? Come on. Quick. Tell me formula for this one.
This is equals to R1 plus R2 plus R3 for series combination.
Yes, that resistance. Now series combination of capacitors. Okay. So you know Q equals to CV. Now if I draw a number of series combination capacitors. Okay. So in that charge is flowing same. C1, C2, C3, here V1, V2, V3. So Q equals to C1, V1, same Q equals to C2, V2, same Q equals to C3, V3. So V1 plus V2 plus V3, V equals to, so if we substitute this value, V value Q by C, it will be Q by C equals to Q by C1 plus Q by C2 plus Q by C3. So this will give you 1 by C equals to 1 by C1 plus 1 by C2 plus 1 by C3 and 1 by Cn. This is your series combination. Equivalent capacitance. Now same way parallel. For resistance, what was the formula? For resistance, what was the formula? Quick.
1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R10.
Very good. So it will be opposite of resistors. Combination of capacitor. Keep doing, come on, don't wait for me. I'm just going to write a formula here. So in this one, V is common. As usual, we have Q1, Q2, Q3 for C1, C2, C3. V equals to Q1 by C1, Q2 by C2, Q3 by C3. So C equivalent equals to C1 plus C2 plus C3. because Q equals to Q1 plus Q2 plus Q3. So if we substitute these values, we'll get C equals to C1 plus C2 plus C3. C equivalent. Here charge divide. Okay. Here charge divide as current was dividing, but we are getting voltage same here also, in that also. Everywhere one concept is same. What is it? Voltage common. If we give a same terms which we are using in series and resistors, it is voltage same, current divide. Right? In this one, instead of current, we have charge divide. Here, charge same, voltage divide. Same thing. It is same concept as resistors, but we are getting a final form different because of our formula. Formula is Q equals to CV.
Sir, can you once show the formula for series?
Sure.
Sir, for the series, what is the final formula, sir?
This one. I didn't block it. This is your final form. 1 by C equals to 1 by C1 plus 1 by C2 plus 1 by C3. And parallel, see, if you are still getting confused with this one, then substitute value of this Q. Here we are adding voltage because voltage is differing. Total V equals to V1 plus V2 plus V3. Here total charge equals to Q1 plus Q2 plus Q3. So substitute value of this Q, you will get CV. Right? Q equals CV. C1 V plus C2 V plus C3 V. So V will be common outside, ruled out. So we will get C equals to C1 plus C2 plus C3. Got it? Some important some important related formula I'm going to write. Okay. Make a note of it because it's not there in, I think, so many book. I don't know which book you're using, whatever. But this formula is specially used for JEE exams when they are using, when they give directly, we will use it. Substitute values and directly. Oh my gosh. Excuse me. Yeah. So let's make it as a note, or let's make it as not note. Keep in memory. It's not for board exams. Okay, so first one. So if the capacitor of parallel plate having number of slabs thickness T1, T2, and so on. Constant K1, K2, K3, and so on. So if I draw a plate like this, a two parallel plate plus and minus, in that between there are some slabs. Name it as K1, K2, and so on. Thickness T1, T2. So your formula C will be epsilon naught A T1 by K plus T2 by K, I'm sorry, K1, K2, and so on. This is not required for a CBSE board exam, but maybe ICSE board exam required. But it is important for your competitive exam. Second formula. Done writing? Shall I scroll?
Yes, sir.
We saw thickness. Now let's change area now. But number of dielectric slabs of same thickness D. They gave same thickness D and different area. There there was thickness different, like T1, T2, T3. Here we have thickness same but different area. A1, A2, so on. Constant K1, K2, K3, and so on. So if I draw here, A1, A2, A3, and so on. Thickness same. Okay. So formula will be C equals to same. K1, A1 plus K2, A2 plus so on divided by D. Third one, there is one more formula, but we will use that in current electricity. So let it be. But no, while solving, we need this. Some questions will be there. Like Wheatstone bridge, if you remember, It's about Wheatstone bridge. When 5 capacitors, those who don't know Wheatstone bridge right now, for the time being, just okay, so for time being, you just understand this way. That these are 5 capacitors, such a way they have combination. Okay, so when C1, let's me give a name, C1, C2, C3, C4, and this is C5. When C1, C2 equals to C4, C3. When C1, C2 equals to C4, C3, when these ratios are equal, that time C5 will be eliminated. So this C5 will be eliminated. It will be ineffective. If this is there, it is called balanced Wheatstone bridge. So in this one, we will study in detail about current electricity. Wheatstone bridge, we have one big topic for that. Anyhow, we are going to use this one, so I'm giving you a small thing like when there is a balanced Wheatstone bridge, how to know this is balanced? When C1 by C2 equals to C4 by C3. This ratio, when these ratios are equal, that time we can say it is a balanced Wheatstone bridge, and fifth one, which is inside, it will be ineffective. So that we will remove this one and we'll count these two as a series, these two series, then these two parallel. So tomorrow we'll see what about like energy stored in capacitors, charging, discharging. What else? Van de Graaff generator. And some previous year papers, not from this book. We'll see from some other PDF. I have PDF for previous years, which I'm giving you as an exam question. Okay, so now for now we'll do some questions. We have some time. Okay, let's do question. An exam question at least we can do. Yes, yeah, this is good. An air capacitor of capacity C equals to 10 microfarad is connected constant volt battery voltage. Now space between the plates is filled with liquid of dielectric constant phi. The charge, the additional charge flows now from battery to capacitor is. So for this, I don't have answer, but I have option here. 120 micro, 600 micro, 480 micro, and D 24. I don't have answer for this one. Even I need to solve. So you write this question and complete with the question which I'm going to send that. Okay, let me take a shot.